So in this video, we're going to talk about how to evaluate logarithmic expressions. So remember, we talked about exponential equations in the previous unit. Remember that we had this property of equality that you can use to solve exponential equations. It tells us that if a is a positive number other than 1, then if a to the x equals a to the y, that means that x equals y. Right? If we have the same base on either side of the equation, we can set the two exponents equal to each other. So what if we want to solve 3 to the x equals 81? Remember, what we're going to do is we're going to look at our squares and powers chart and see where we can find both 3 and 81. Notice that they're both powers of 3. So this 81 I'm going to rewrite as 3 to the 4th. So I have 3 to the x equals 3 to the 4th. So now I have the same base on either side, so I can set the exponents equal to each other. So that gives me x equals 4. So you can use this process to evaluate logarithmic expressions. So suppose it asks you, what is the log base b of y? So what you're going to do is you're going to set the logarithmic expression equal to x. Okay, so I'm going to rewrite this as the log base b of y equals x, because x is the unknown that I'm trying to find. Remember that we can rewrite this now in exponential form. So I can rewrite this as b to the x equals y. So now what you can do is you can use the powers chart to rewrite this equation so that you have the same base on either side, right? Because it's an exponential equation. Then we're going to set the exponents equal to each other and solve. So basically what you're doing when you're trying to solve this problem is you're saying what power of b gives you y, right? Because we rewrote it as an exponential equation and we're trying to say, well, what is this exponent that I can put on b that will give me an answer of y? So for example, let's try solving the log base 4 of 32 equals x. So I'm going to rewrite this in exponential form. So I have 4 to the x equals 32. So I'm going to look at my squares and powers chart and notice that both 4 and 32 appear as powers of 2. So the 4 I'm going to rewrite as 2 to the 2, that's the x power, and that equals 32, which is 2 to the 5th. So now I have a power raised to a power, right? So I have a to the m to the n. So I'm going to multiply the two exponents together and get a to the m times n. So 2 times x is going to give me 2x. So I have 2 to the 2x equals 2 to the 5th. And so now I have the same base on either side, so I can set the two exponents equal to each other. So I have 2x equals 5. I can now solve this by dividing both sides by 2, which gives me x equals 2.5. So in this problem, it says evaluate the log base 5 of 125. So even though it's not set equal to anything, I can just say this equals x, right? Because x is the unknown that I'm trying to find. So I can go ahead and rewrite this in exponential form. So I have 5 to the x equals 125. If I look at my squares and powers chart, I notice that 5 and 125 are both powers of 5. So I can rewrite this as 5 to the x equals 5 cubed. So now I can set the exponents equal to each other, so I have x equals 3. So now let's try evaluating the log base 4 of 16. So once again, I'm going to set this equal to x. I'm going to rewrite in exponential form, so I have 4 to the x equals 16. So you may notice that these are both powers of 2, so I can rewrite this as 2 squared to the x equals 2 to the 4th. So I have 2 to the 2x equals 2 to the 4th. So I can say that 2x equals 4, and I can solve by dividing both sides by 2. So I have x equals 2. You may have solved this problem a different way. You may have also noticed that these are both powers of 4. So at this step right here, instead of doing what I did, you could have said that 4 to the x equals 4 squared, and then set the exponents equal to each other, and you still get x equals 2. Okay, so sometimes there's more than one way to go about solving these problems. So now let's try evaluating the log base 36 of 6. So once again, we're going to set it equal to x. So we're going to say that 36 to the x equals 6. So if we look at our squares and powers chart, we're going to notice that these are both powers of 6. So we're going to say that 36, we're going to rewrite it as 6 squared. So we have 6 squared to the x equals 6, right? Remember that 6 by itself is basically a 6 to the 1. So when we multiply those exponents, we have 6 to the 2x equals 6 to the 1. So we can say that 2x equals 1, And then we can solve by dividing both sides by 2. So when we do that, we get x equals 1/2. Or you can write it as x equals 0.5 if you prefer decimals. So now let's try evaluating the log base 5 of 0.2. So I'm going to set it equal to x. And then what I'm going to do is I'm going to say that this is 5 to the x equals 0.2. So this is kind of an interesting example. And the reason I included it on here is because I know 0.2 is not on your powers chart. But I just want to show you how you can kind of figure this out. You can convert the 0.2 to a fraction. Remember, you can use the arrow to fraction button on your calculator. And then if you do that, it'll tell you that 0.2 is equal to 1/5. Okay, so I can rewrite this as 5 to the x equals 1/5. Right, so that's basically a 1/5 to the 1. And remember, we have that reciprocal property. So like if we have a to the negative n, remember that equals 1/a to the n. So I can rewrite this as 5 to the x equals 5 to the negative 1. Okay, so now I have the same base, so I can set the exponents equal to each other. So I can say that x equals -1. So that's how you would solve this problem. So now you can pause the video and try this example on your own. So we're trying to figure out the log base 2 of 32. So if we rewrite it, we get 2 to the x equals 32. 32 is a power of 2, so we have 2 to the x equals 2 to the 5th. And when we set the exponents equal to each other, we have x equals 5. So remember that logarithms are the inverses of exponential functions. And remember that the log base b of y equals x means that b to the x equals y. You can use this idea to solve a lot of logarithmic expressions.